Okay, so we're going to start with our notes on polynomials today. They should be fairly short, not too bad. So polynomials are expressions made up of terms where all exponents are positive whole numbers. So a few things kind of with this. So no negative exponents. No variable exponents. No radicals. Radicals are our square roots or our cube roots, any kind of roots. And no variables in the denominator. So we'll just do a few examples to determine. So determine if each expression is a polynomial. So we'll do A is 5x squared. I'll just write them all out and then we'll go over each one. B is 7x. C is negative 11. D is the square root of 5x. E is 7 to the power of x. And then F is 1 over j to the third. Okay. So I would like it if you guys could kind of chime in as we go through these, just saying yes or no really quickly, and then we'll go over each one, which means you would need to unmute yourselves. I could do it for you if you wanted. And if you're not sure, that's okay. And if we make mistakes, that's okay too. What do we think on A? Is A a polynomial, yes or no? Anyone? Everyone? I can call on people. No one likes that though. Hopefully everyone can just say yes or no at the same time. So is A a polynomial? Or put it in the chat. You could do that. That's easier if you prefer. I can open my chat up again. A. So we're getting yeses there so far. 5x squared. So it's made up of terms where all exponents, so our exponent is a positive whole number. Perfect. What about B? Is B a polynomial, yes or no? Or I'm not sure. You can put I don't know or a question mark just to show me that you're paying attention, but maybe you don't know one way or another. So yes or no, or like I said, a question mark or IDK, however you want to do that. So B is also a polynomial because there's no exponent on the x. Can you be quiet, please? So there's no exponent on the x, which means that our exponent is a 1 that we just don't write. So that one is still a polynomial. And C, what are our thoughts on C? Yes or no?
No.
No. Why not?
Because it's negative. Is it negative?
It's negative, but it says, so this just says no negative exponents. So the number is a negative, and that's okay. So C is actually a polynomial still.
So the whole number can be a negative?
Yeah.
Okay.
Yep. So yes, the numbers can be negative or positive. Or sorry, just the coefficient in front. This is kind of like with an x to the 0 that we don't write. So our numbers can be negative there. Exponents can't be negative. D is not. Why not? Someone want to say why not?
Is it because there's a radical?
Yep, perfect. Because it has a radical in it. E is also no. Why?
It has an exponent.
So it has a variable exponent. So our exponential equations, those are not going to be polynomials. And then F is also another no. We have a variable in the denominator. Which we may or may not remember, that's the same thing as a negative exponent, if we wrote it differently. Okay. So that's it on those notes. We're going to do a few example problems. So chapter 1, review notes. So I'm going to work out some problems that are going to be similar to the problems you have on your assignment today. So if I'm going too fast or something doesn't make sense, speak up or type it in the chat. Just let me know. So evaluate each function. So h of x equals 2 times the absolute value of x plus 3 with a minus 3 outside the absolute value, and we want to find h of negative 4. So here we just plug in negative 4. And again, this should pretty much all be review. So negative 4 plus 3, and then a minus 3. So remember, you do inside your absolute value first. Even though absolute value makes everything negative, you always simplify inside there first. So negative 4 plus 3, we get negative 1 minus 3. And then the absolute value of negative 1 we know is just 1. So 2 times 1 is 2 minus 3, we get negative 1. Number 2 is f of n equals n squared minus 4n, and we need to find f of n minus 3. So here we're plugging in an expression instead of a number. So anywhere we see an n, now we're plugging in n minus 3. So n minus 3 squared minus 4 times n minus 3. You want to make sure you put it in parentheses so that you follow the correct order of operations. So here for this n minus 3 squared, you're going to need to make a box, or some of you might use FOIL. Whatever method you use is fine. But remember, you have to square the whole binomial. You don't just square each term.
Miss Rice, could you push your notebook up a little bit?
Is that better?
Yeah, way better.
So n squared, negative 3n, and 9. So again, this first part we made a box. So n minus 3 squared becomes n squared minus 6n plus 9. That's a positive 9. And then for this second part, we distribute the negative 4. So minus 4n plus 12. We end up getting n squared minus 10n plus 21. All right, give a few more seconds and then I'm gonna turn the paper over since I'm running out of space here. So number 3 is f of x equals -1 minus 4x plus 8x. And we need to find x if f of x is equal to -17. So this one's a little bit different because it's f of x equals something. So in this one, we need to set our original expression on the right equal to -17. So -17 is equal to -1 minus 4x plus 8x because we're looking for x in this problem. And then you can, depending on how you solve this, some of you might add 1 first, some of you might combine your like terms first. Personally, I'd combine my like terms. -4x plus 8x, I get plus 4x. Add 1 to both sides. -16 equals 4x. Divide by 4. -4 is equal to x. On number 4, we have a system of equations. I'm not going to write the directions for each of these because it's just not necessary, I don't think. So when they're both y equals something, you just set them equal to each other. So -6x plus 19 is equal to 5x minus 14. So we can, remember you can do any of 4 things. You can add 6x, subtract 19, subtract 5x, or add 14 to both sides. I'm just gonna subtract 5x. -11x plus 19 equals -14. If I subtract 19, then -11x equals -33. Divide by -11, and I get x is equal to 3. But we're not done on this problem. Remember, this problem was a system of equations. We had both x and y. So we only got x, we still need to find y. So to find y, we take 3 and plug it into x. It doesn't matter which equation you plug it into. It's best if you plug it into both to check your answer. But as long as you plug it into one of them. So -6 times 3 plus 19. So -18 plus 19 is equal to 1. I'm going to also plug it into the bottom equation just to confirm my answer. So again, plug 3 in for x, and I should get 1 again. 15 minus 14 is equal to 1. So y is equal to 1 for both of those. If you get different answers, that just means you made a mistake somewhere. So your answer here is the ordered pair 3, 1. Always x and then y. Let me get down number 5. 2x squared minus 10x minus 28 equals 0. And it just says solve each equation. So again, just says solve the equation. Here we have a quadratic equation, which hopefully you recognize because it has an x squared in it. Anytime x squared or a squared is your highest variable, it's a quadratic. So the first thing I notice when I go to solve this problem is that everything is divisible by 2 on this left side. So I'm going to divide everything by 2 just so I have smaller numbers. You don't have to do that. If you don't recognize that, you'll still get the same answer. You just might have to do more simplifying at the end. So if I divide by 2, now I have x squared minus 5x minus 14 equals 0. 0 divided by 2 is still just 0. It's kind of like factoring out the 2 on the left, but because it's an equation, I can just divide by it. So I'm going to factor this one. But you remember the quadratic formula always works. I'll do that one on the next problem though. So I wanted to just kind of review factoring here.
Miss Rice?
Yep, move
Can
up.
you just get your notebook up again?
Yep,
Thank you.
sorry, thank you for reminding me.
You're good.
So again, you could complete the square, you could do quadratic formula. It's up to you when you're doing your practice problems. So again, these are like problems you'll be doing in your assignment today. So x squared and negative 14. We multiply, so the first term and the last term, you multiply to get here. And then your middle term goes on the bottom. And I'm going a little quick because most of this should be review, but if you need me to go over something kind of after I've done all of them to go a little bit slower or explain something again, just let me know, please. So we're looking for two numbers here that have a product of negative 14 and a sum of negative 5. What do we got?
7 and negative 2.
Perfect. 7x and negative 2x. Oh, nope. What's wrong with that? Sorry. What's 7 minus 2?
5.
5.
Oh, positive 5.
Yeah, we want negative 5, so we need to switch these signs.
Yeah, switch them.
Negative 7x and positive 2x. And again, it doesn't matter which one goes in which box. We get x, x, 2, and negative 7. So x minus 7 times x plus 2 is equal to 0. Remember, the zero product property says if you multiply two things together and get 0, one of them is 0. So we have x minus 7 equals 0 and x plus 2 equals 0. So x equals 7 and x equals negative 2.
Wait, how does x equal -2?
because you subtract 2 on both sides.
Oh, okay. I understand.
Okay, so on number 6, it's another quadratic. I actually lied before I said I was going to do the quadratic formula. You are welcome to do the quadratic formula here. If you do the quadratic formula here, A is 11, B is 0, and C is 9. So I'll write that down, even though that's not what I'm going to do. You are welcome to. Anytime your B is 0, you can just, what's it called? Take the square root at the end, but you can just subtract the 9. So again, if B is 0, I'm going to kind of put a star here to show you why I'm solving it this way. We can subtract 9. We get 11x squared equals -9. We don't square root yet. You don't square root until you get your x squared alone. We divide by 11. And now we have x squared equals -9 over 11. And this is kind of a hard one to show you this example on, but I'd rather we do a hard one in class with our notes than on your own assignment. So from here, again, if you don't like this method, the quadratic formula will always work. But from here, we can square root both sides. Remember a couple things. The square root of x squared is x. We were really asking ourselves before I took the square root, what number when I square it gives me this? So remember, your answer over here is going to be a plus or minus. Does anyone remember the square root of -9? So the square root of 9 is 3, but what happens when we have a negative there?
Goes into an I.
It becomes an I. So we have plus or minus 3i over the square root of 11. So when you take the square root of a fraction, you can take the square root of the numerator and the square root of the denominator separately. We still have a problem with this though. So going back, we can't leave a square root in our denominator. That's what we call rationalizing the denominator. So because we have the square root of 11 in our denominator, we want to multiply by the square root of 11 over the square root of 11. Really, we're multiplying by a big 1. It just looks funny. Anything divided by itself is 1. So multiplying fractions, we go straight across. So our numerator is 3i root 11. In our denominator, root 11 times root 11 is the square root of 121, which the square root of 121 is just 11. So some of you may skip this middle step and you might realize when I multiply this by itself, the squared and square root cancel. If not, that middle step only took an extra, 5 seconds? Again, I don't think you have one this hard in your classwork from what I recall. But this was a lot of steps that hopefully are coming back to you. You may not have remembered if I just gave you that problem, but now that you've seen it, hopefully that looks familiar. Number 7 just wants us to graph f of x equals 1 over x plus 2. Does anyone remember, there we go, moved it up a little bit, where our asymptotes are if we're graphing f of x equals 1 over x plus 2? And if you need to flip back a couple pages in your notebook, you're welcome to do that. That's what we did on Tuesday. Where are the asymptotes? We're going to have 2. We're going to have an x asymptote and a y asymptote, a vertical and a horizontal. So on these problems, and we did asymptotes notes yesterday with something similar, when there's nothing on the outside here, your asymptote for y equals is always going to be 0. And then remember, what we had originally focused on was f of x equals 1 over x minus h. So in this problem, our h value would be -2 because it's the opposite. So our asymptote is at x equals -2. Which a few of you put that in the chat, some privately, and thank you. So we have that asymptote there. And then we also have this one on the x-axis. Remember, it's going to go kind of like this. Okay. Number 8 is another solve this equation, but now we have fractions in it, so we're going to review fraction busting. So we have a couple of options here, and this will be totally up to you guys if somebody speaks up first or more people say one thing or the other. So most people look at this problem and get a little bit discouraged because it has fractions. So you have the option to either fraction bust and get rid of your fractions right away, or you can distribute and get rid of your parentheses first. Do you guys have a preference? Do we want a fraction bust, or do we want to get rid of distribute first and then fraction bust? Fraction bust?
Fraction bust.
Fraction bust? Okay. So if you want to fraction bust first, we see that our two denominators are 8 and 2. So you always want to multiply by whatever goes into, whatever both of those denominators go into. Since 2 goes into 8, we can just multiply both sides of our equation by 8. And we're going to really multiply by 8 over 1. I should have left more room here. And it doesn't matter. So we're multiplying by 8 over 1. So sure, on this left side, if you guys want, remember to multiply fractions, you go straight across, but you might also remember that if there's an 8 on top and an 8 on bottom, that those are just going to get to cancel out. So this left side just becomes 763. That was the easy part. On the right side, we have two options. Because this is multiplication, it's something times something times something, because this is just one long something inside of the parentheses. Order doesn't matter. So we can distribute the 7, distribute the 8, or we can multiply the 7 and the 8 and then distribute, which is what I'm going to do. So this side becomes negative 7 times 8. We get negative 56 over, or times 9 over 2r plus 1. So again, when you multiply three things together, it doesn't matter what the order is that you multiply them in. And now is where we would distribute. Depending kind of on how some of you make a little box, it doesn't matter. 763 equals. So here, again, you have a couple of options when you go to distribute this. Remember, this is like over 1 when you're multiplying by a fraction. Some of you will simplify first and some of you will distribute first. If you know how to simplify first, go ahead. But if we do 56 times 9, negative 56, we get negative 504 over 2. Again, you multiply just 56 times 9, 1 times 2. Negative 56 times 1, we don't forget the r, sorry, we get minus 56. And then by dividing right here, your fraction should go away. It shouldn't end up being a decimal or anything. 504 divided by 2, negative 252r minus 56. Add 56, we get 819 equals negative 252r. Divide by negative 252. So I want to point something out. When you do this, 819, you're going to get a decimal. When you're doing this worksheet today, it's going to be multiple choice and they're going to be fractions. Because our problem started as a fraction, we would want our answer as a fraction. So we have a couple of options here. You could, if it's multiple choice, you could go through each one, but your calculator will turn this into a fraction for you. Again, I'm not really super picky, but on your multiple choice worksheet, it's going to be fractions and they're going to be simplified. So we can't just leave it as 819 over 252. So to turn this into a decimal on these calculators, you hit math and then you just hit number 1. That just says, I want to turn it into a fraction. And it tells us that we get negative 13 over 4. Which again, we saw was negative 3.25. And some of you might be able to convert negative 3.25 into a fraction because it's smaller numbers. If you have the smaller TI-30 calculators, not the graphing calculators, just the scientific calculator, there's a little button. I think it's like this. F to D, fraction to decimal, or decimal to fraction. If you have that smaller calculator, that's what you're going to hit. or you could probably type it into Google and I'm sure it'll do the conversion for you. We're gonna do one more fraction buster and then that'll be it on here. Does anyone need more time before I flip the page? So last one, here we go, number 9. 99 over 28 minus 8 over 7x equals negative 17 over 7x plus 9 over 2. So again, we want a fraction bust here because, so we look at all of our denominators, 28, 7, and 2. Since 7 and 2 are both factors of 28, we can just multiply everything by 28. So depending on how you learn this, you could put parentheses around both sides and distribute the 28, or you could just write times 28 by everything. It's really the same thing. So depending on how you do this, everyone has different comfort levels. I'm gonna kind of show this the way I teach it in Math 1. So it's gonna be a little bit slower. And if you're more advanced and don't need all of those steps, then that's fine, and go ahead and kind of just make sure you understand what's going on. So by putting the 28, again, we picked 28 because 2, 7, and 28 all go into 28. So by distributing, remember to multiply fractions, you just multiply straight across. So this becomes 28, let me use my other color, sorry. 28 times 99 over 28 minus 28 times 8 over 7 with an x. So again, I'm just putting 28 in front of each of these. Equals 28 times negative 17 over 7 with an x plus 9 times 28 over 2. The denominators stay whatever they were because our denominator was 1. So again, you might be thinking this is an extra step. What is she doing? I can just multiply those numbers together. You are more than welcome to just multiply 29 and 88 and 28 and 8 and then reduce them. The reason I like to do it this way is because I like to just kind of simplify first. So right here, 28 over 28, those just go away. That's a big 1. So this first part of our equation just becomes 99. Again, if you were using your calculator, you would have done 28 times 99, and then you would have divided by 28, and you would just get back to 99. Here, 7 goes into 28, so this 28 becomes a 4. So 4 times 8, we get minus 32x. Again, if you're like, what? You could just do 28 times 8 before I simplified and then divide by 7, and you're gonna get the same thing. So it's just, I think it's helpful to understand this way because especially if you don't have a calculator, you're gonna want some of these smaller numbers. So again, that crosses out and that becomes a 4. So 4 times negative 17, we get negative 68x. 2 goes into 28 14 times. So 9 times 14 is 126. Again, this is what I was saying. This is kind of very, very basic elementary math 1 level, how it's originally taught. Some of you are going to do that from the beginning, but what you want to be careful with on this first step, if you try to do it at the beginning, you don't want to just cross these 28s out, because then you still, some people do that and then they forget to distribute it to this thing. But if you wanted to just do 28 times 99 divided by 28, some of you are going to skip this middle step here. That's fine. As long as I can kind of see what happened and you are showing your work, I'm good with that. So from here, it's just a basic equation, which I'm sure we all remember how to solve, and you should get x equals 3/4. I wanted to go over this one to make sure we reviewed fraction busting a little more. Do we have any questions on that? So tomorrow what you're going to do is you're going to take the diagnostic test. Again, please don't cheat and use photo math. Don't look anything up. You're not, if you don't do well, we're not saying, hey, you have to move back to math 2. It's to see where you are now. But if you're looking everything up, I think you know it, and we're not going to spend time reviewing those concepts. So please try to just be honest with yourself about what you know, and be honest with me, because then we're going to take the same test either 1 or 2 more times this semester to look for growth. So if you look everything up now, you'll have to look it all up again later. So for tomorrow, it's going to be at your own pace. It is the first time we're using this new program, and it is, so I don't know all of the details. It is an adaptive test. I don't know how many problems it is. Adaptive means as you're answering questions, the next question will change based on your answer, if you're getting them right or wrong. So I don't know. You may all have the same number of questions. You may not. If you're just going through and guessing quickly, it will lock you out until, it'll warn you first, but it'll tell you that you're not spending enough time on a problem. So the way it's going to work tomorrow, I will post the directions in Google Classroom, hopefully by 8 a.m. We have a meeting after school today to kind of work out all of the last minute details. So your directions for tomorrow will be posted in Google Classroom. You need to log in and start the test by 10 a.m. You all have to get up at 8:30 for access anyways. You don't have to take the test, but once you kind of, it's like the practice test we did hopefully in your math class last year. Once you open it, I have to approve you. So I plan on sitting or being nearby my computer from 8:15 to 10 a.m. And approving people as they come in. That doesn't mean you have to take it and do the whole thing right then. You just have to get it opened then while I'm there approving it. And if it takes me a couple of minutes because I'm doing something and not just constantly hitting refresh, please just be patient. And the 10 a.m. is technically when our class time is supposed to start. That's kind of why I'm putting it there. It should just be a link that you click on, and I will give you, I think it's like a session ID and a passcode that you'll have to type in. If issues come up, please just email me. I should be by my computer or have my phone with me most of the day. I expect issues to come up. This is the first time we're using this new program, and we're going to figure it out together. That's why I asked you guys to run that diagnostic to make sure your computer was up to speed, and most of you did that, I think. And we troubleshot a lot of those and got most of them figured out. So that's for tomorrow. Look for the directions in Google Classroom. If you have issues, email me. And like I said, be patient. you should get approved, I'm gonna say within 10 minutes. Just make sure you kind of try to get signed in there by 10 a.m. because I have a meeting at 10 a.m. All right, so for your assignment today, you are using that Kuda Works. I don't know, we were working with the district to get, some of you have not set up your account yet. And so some of you set it up, but you never went into your email to verify your email account. So if you have not done that, that's what you need to do now. We were working with the district to get them to come through the district email. I don't know if they got that figured out by now, which means you may have to use a personal email. But go to Kuda Works. It is, I can open the link if it's easier to share it in here from Google Classroom. Someone asked a question. So your test tomorrow should be done by 4 p.m. Let's say 3:10 is when school ends because I'm supposed to have attendance done by 4 o'clock. And that's going to be how you get attendance taken for tomorrow is by taking that test. So just by the end of the school day, if it's kind of overwhelming and you need to take a break, as far as I know, it lets you walk away. If I find out new information in my meeting today, I will let you know. Okay, I'm getting into Classroom to get you guys that link. But your assignment should be there. Again, we've done Kuda worksheets before.
Battery low.
But now this is, basically you get to do it online. You can either, to show me your work, you can print the assignment if you want, but you can just work the problems out in your notebook as I did today. So there's the link, sign in. If you get signed in and your assignment's there, you are free to go and that's all you are doing today. If you need help with something, technical, like you can't get logged in, I need to approve your account, you're still having issues, let me know.